All right, let me just explain a few things. Okay, so next week is our final exam. It's the last time we will see you guys, so I will miss you, and I know you will miss me and statistics as well. So the feeling is mutual. That said, the final exam is worth a lot. Okay, it's worth 35%. So prepare. Okay, it's going to be all multiple choice and all Scantron. There's 50 questions, 46 count, and 4 will be bonus, okay? So you can get a total of 109% if you get all 50 questions right, okay, which I think is pretty generous. And so everybody should have also received an email from me with your current standing, okay? If you notice any problem, okay, let me know right away. It has to be taken care of before the final exam, because after the final exam I submit final grades, and there's no changes after that, okay? So if you notice a mistake, let me know right away, okay? The email should have made it very clear as to exactly what you need on the test to get a certain grade. So if it says you need an 83.7 on the final exam to get a B, that means you need an 83.7 to get a final exam, okay? If you get an 83 or an 82.5, you won't get the B, all right? Don't email me saying, I came so close, all right? That's offensive, okay? I've done everything for you, okay? And you know exactly what's required of you, okay? So there should be no surprises. So, you know, if you barely miss, you know, like you're shooting for a C, you're shooting to pass, and if you just barely miss it, you know, at that point I have to say that's on you, okay? And don't send me your sob story, okay? It's not that I don't care, all right? But I have to draw the line somewhere. I have to say this is it. I've got to maintain, you know, my standards for the course. So you know what's required of you, and you have to do that. Okay. All right. Are there any questions? Yes.
Okay. So you know, like on the quarter, or like over here, like a B minus B, whatever. So let's say like we get a B, but it like if we like our community college is like a B minus would be a B, right? Like it wouldn't.
So that depends on where you are transferring your grades to. Okay. So if you come to UCLA, a B minus is different from a B, which is different from a B plus. Okay. So if you transfer your grade to UCLA and you earned a B minus, it goes into your grade report as a B minus, and that's different. It depends on your school. If your school is different, if they say pluses and minuses, we don't care, that's up to your school. So I can't answer that question. That's up to the school where you are transferring your grades. I just know here at UCLA it's different. So I report the pluses and the minuses and all of that. Your school might not care. Okay. At UCLA, a C is a pass, but a C minus is not. Okay, so I don't do C minuses. All right, I just do C. If you get a 70%, I'll give you a C. Okay, and you know, other professors might say C minus, and that technically means you have to retake the course if you're at UCLA. But I'll do if you get a 70%, that's a C. You can move on with your life. Okay.
When did you send the email?
I sent it this morning at around 7 a.m., 6:45, something like that. Okay. Got up early, put on the final touches, and did the blast. Okay.
Sir.
Yes. Question.
How soon will we know our grade after
How
the final?
soon should you know your final grade? Okay. Within 1 week after you take the final. Okay. So I try to get them out by Saturday, but you know, give me until like Tuesday of the following week. Okay. Any questions about anything? All right. So today we'll go through the practice final exam, which which I think is a pretty good way to prepare for the final exam. Okay. Your assignment last week was, to do that part and then also to work through this. And so we'll go through all of the answers here. If you have any questions, now is the time to ask. Next week, I will not have office hours. Okay, so no office hours next week. Just show up here at a little bit before 6:30. Okay, we'll have you guys seated. Open seat between everybody, all of that stuff. And then you guys will have until basically 9:30 to take your test. It's not too terrible. All right. It'll be okay. All right. Okay. Yes, Marcel. Yes, I will not stay here forever. Okay. It's like 2 hours and 50 minutes. Okay. So a little shy of 3 hours. You are allowed one note sheet, front and back. Okay. I've created a study guide for you, which you can use this as your note sheet. You can't use this and a separate note sheet. Okay. You get one sheet of paper, front and back. All right. And I will be strict. Okay. If you have, so some people said, can I have 2 sheets if I write only on one side? That is okay. But, all right, because they said, I don't know, the pen leaks through or something, I don't know, whatever. 2 sheets, blank on one side, writing on the other, that's okay. I'll let that slide.
And
Okay,
just staple
but,
them.
Huh?
Staple them.
Well, but if you have writing on this side and this side's supposed to be blank, but there's writing on this side, then I will only let you use one of those 2 sheets. Okay, so if you're gonna go with 2 sheets, writing on one side and blank on the other, make sure the other side is completely blank. Okay, don't push your luck on the day of the final. All right, we'll say that. Okay, I don't want to ruin anybody's lives, but if you're gonna try to be unfair and take advantage of me, I won't stand for that. Okay. All right. Anything else? Any other questions?
Who is the email from?
It's from me.
Miles Chen?
It's from mileschen@gmail. It should say StatsXL 10 grades before the final. Okay, I can resend the email to you if you didn't get it. All right. Okay. Well, in that case, then we'll get started. Okay. And unless somebody has some better plan, I'm just going to start at problem 1 and I'll work through problem, what's the last one, 60 something? Okay. And we'll get through this entire thing within our time span here. And that's with me working through everything and talking. So it's more than enough time. This is longer than the actual final, so it's more than enough time. I don't know what step 7 is. This has been my life for the past 4 years or whatever, how long I've been teaching. All the good years that are on the days I teach.
I found it.
Huh?
I found it.
Okay, great.
You found it? I found it.
Okay, all right. Practice final exam. Questions 1 through 4 are any of the conditions violated? Yes or no? Okay. So, I hope you guys all have a copy of this. Okay, because I'm not going to rewrite all the problems up on the board. That's a waste of my time. So, number 1 says a study is performed to understand the relationship between bright lights and headaches. 80 randomly selected subjects are exposed to bright lights, and 20 complain they experience headaches. 90 subjects, randomly selected subjects, are exposed to less bright lights, and 12 complain about headaches. Are any conditions violated? Okay, so number one, let's check. Is the independent random assumption met or violated?
Met.
That's met. Okay, so independent, that one is met. All right. What about big population? All right. What are the populations that we are talking about here? So no, those are our samples. One sample is 80 randomly selected subjects, and the other sample is 90 randomly selected subjects. What is the the respective population for the 80 is everyone who could be exposed to bright lights. All right. Everyone with bright lights, and the other population is everyone with less bright lights. I should write dimmer lights. But okay, so everyone who could be exposed to bright lights, is that over 80 times 10? Is that over 800? Yeah, there's probably millions of people. And less bright lights? Yeah, also more than 900. So that's also met. Okay, so big population is met. Large sample. Okay, are we dealing with means or proportions here? Proportions, right? Did they get a headache or not? That's a categorical variable, so we have proportions. Okay, so when we have proportions for the large sample, we're checking n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Or success is over 10 and failure is over 10. Alright, so for group 1, how many people had headaches?
20.
We had 80 people total. 20 had headaches. Okay, so 20 headaches, that's over 10. So that's over 10 successes. So how many people did not have headaches in group 1? 60, right? 60 no headaches. Also greater than 10. Okay, group 2, 12 had headaches. That's over 10. And then group 2, how many people didn't have headaches? 78. No headache. Also greater than 10. Okay, so all of these numbers are bigger than 10. So our large sample condition is met.
So you can't combine the groups together.
Yeah, don't combine the groups together when you have 2 samples. 2 samples, you're just checking n successes and failures are np and n1 minus p for each of them. Okay, so there's a whole bunch to check. It's a little bit of a pain, but it's not hard. It's just a little bit of extra work.
So if you have like a percentage instead?
Yeah, if you had a percentage, you would do the n times p. Okay, so here we had counts. It said this many people had headaches, so we just check if that's bigger than 10.
So we don't do the n.
Yeah, you don't have to do NP for this one. If you're given a percentage, then you use the NP. Is that okay?
Wait.
Can you repeat that?
Repeat that? Yeah. So in the problem, I gave you a count. I said this many people had headaches. This many people didn't, or whatever. So those are counts. So you just compare the counts directly to 10. So it said 12 people had headaches. 12 is bigger than 10. So that means how many didn't have a headache? 90 minus 12, or 78. 78 is bigger than 10. On the other hand, so number 2, we're going to see percentages, and we will use the percentage to check large sample. So number 1, all conditions are met, so the answer is E. It doesn't violate anything. Or I'm sorry, D. Okay. Number 2, we want to make a confidence interval for how common a certain disease is. He finds 300 randomly selected subjects, and 2% have the disease. Are any conditions violated? So, independent condition, is that met? Yeah, it says they were selected randomly. Okay. Big population. What is it says we selected 300 people. But what's our population? This is anybody who might be exposed to the disease or just the general population. So is that going to be over 3,000? Yes. Okay. Large sample. So in this case, we want to check n times p. So my n is 300, and my p is 2%, 0.02. Okay, so n times p is equal to 6, and n times 1 minus p, 294. Okay, this one's bigger than 10, but this one is not bigger than 10. So the large sample condition is violated. So the answer is C. Questions? Good? Alright. Says a student has to conduct a survey for a school project. He goes around campus and interviews people he meets. Interviews 100 and 45 say yes. Okay. What was violated there? Independent is violated, right? Employees, and it decides to survey 100 and interview them. Alright, so independent, it says they were randomly selected. So that's met. Big population. Okay, our population has 800 people. And our sample has 100. Okay, so 10 times 100 is 1,000. This is bigger than my population, so the big population condition is not met. It's bad. Okay, so you will see some questions like that on the final exam. Of course, everything's going to be different, but it'll be similar, right? Alright. Okay, so 5 through 10, it says, a farm wants to test 2 different diets for their cows to see which diet causes more weight gain. They randomly select 10 cows to give diet 1 and 12 cows for diet 2. After 2 weeks on diet 1, the 10 cows gained an average of 15.2 pounds. There's a standard deviation of 4.1. 2 weeks on diet 2, 12 cows gained an average of 12.6 pounds with a standard deviation of 3.4. The following questions refer to a 95% confidence interval for the difference in average weight gain. Okay, so first off, this is the most important part. So all of these questions that you're going to have, you have to decide, do I have 1 sample or 2 samples? Am I dealing with means or am I dealing with proportions? Okay, that's the most important step. If you get that wrong, everything is lost. Okay? So what do we have? We have 1 sample or 2 samples? 2 samples, right? And am I dealing with means or proportions? Means. Okay, so I got 2 sample means. And the problem says we're doing confidence intervals. Okay? So if you have the study guide, I tried to make this as helpful as possible. But, you know, your brain might organize things differently from my brain. So this is organized in a way that made sense to me, but maybe it doesn't make sense to you. Okay, so it says for questions about confidence intervals, you should be able to answer the following questions, and then it lists them off, and it lists out, you know, if you have 1 sample proportion or 1 sample mean or 2 sample means. So in all of these things, we're dealing with 2 sample means. So you're going to see, when it says what is the center, it says for two sample means, it's the difference between the sample means x bar 1 minus x bar 2. Okay, so anyway, once you figure out that it's two sample means, I don't have this written on the study guide, but you should take the time to identify all the bits of information that you do have, okay? So, for two sample means, we're going to have an N1, an X bar 1, and an S1, and an N2, an X bar 2, and an S2. Okay? So, we will go through and identify these. What is my N1? If we're talking about diet 1, N1 is
10.
We have 10 cows. And what's N2? 12 cows. Okay, X bar 1 says they gained an average of 15.2, and over here they gained an average of 12.6. And over here the standard deviation was 4.1, and the standard deviation here is 3.4. Okay? So, most important, identifying one sample, two samples, means or proportions. And then, just to make your life easier, I like to pick out and identify all of the things, okay? The N1s, or the X's, and the S bars, or the P's, and the whatever you need to do, okay? And then we can go on. All right. So, number 5, what's the center of the interval? That's going to be x bar 1 minus x bar 2. That's written in your study guide, or just look at the problem, and we see that the difference is 2.6. That's going to be the center. What value will you use for T star? Okay, so for T star, we look up n minus 1 degrees of freedom. And which n do I use? The smaller one. So I do 10 minus 1, I have 9 degrees of freedom. And I'm making a 95% confidence interval. And this is rather weird. Okay, so somebody will have to tell me.
You want a book?
2.262. Yeah, I wrote all of these answers. Okay, so my T star is 2.262. Okay, that's directly from the T table. Again, I'm just powering through all of these questions. If along at any step you say, wait, how did you get that number? Just raise your hand and say, I've got a question. Number 7, what's the standard error? Okay, so two sample means confidence intervals. The standard error is going to be S1 squared over N1 plus S2 squared over N2. Alright? So you just got to check your notes or your study guide or whatever it might be. You just have to know two sample means, confidence interval, my standard error is this. That's it, okay? Again, most important step because that will decide what you use here. So here it's just a matter of plugging in these numbers, 4.1 squared over 10 plus 3.4 squared over 12. And when you punch all of that in, I get 1.626. Okay? Might be a good time to verify that you can use your calculator well. Okay. Oh, please double check and make sure your calculator works on the day of the final, okay? And it might not be a bad idea to bring some extra batteries if your calculator uses batteries, okay? If your calculator dies on the day of the final, there's nothing I can do, okay? I just have to say, I'm sorry, do your best. A lot of the questions you can do quite a bit without a calculator, but your life will certainly be more difficult.
How do you calculate that on the calculator?
Okay, do you have that kind of calculator? Yeah. So type in 4.1, and you should have a square button, division sign 10, plus 3.4 square button, division sign 12. Then hit enter.
So you use parentheses?
I don't think you need to use parentheses actually. And then you do the square root of that answer. I like to do it in 2 steps. Okay.
Okay, yeah.
Okay, you got that? Good. Yes.
You want to use after the decimal 3 numbers, up to 3?
You know, it's multiple choice.
I put 4.
Okay. You can have 4. That's allowed. All right. So multiple choice. So the way I write my answers is in my calculations, I don't do any rounding except when I put them onto the answer sheet. Okay. So in all the steps, I don't do any rounding, and then I write down the answer. I only round the final answer. So when you look up your answer choice, your answer will probably be very close to one of them. Okay, if it's not exactly, it might be off by 1/1000th or something like that. If that's the case, just go with the closest one. All right. If it's off, like if your answer is way different from all the answers there, you've probably made a mistake. Okay. The correct answer is always available. So there you go. Okay. So now we create a 95% confidence interval. So this is just going to be x bar 1 minus x bar 2 plus or minus t star times my standard error. So I do 2.6 plus or minus 2.262 times 1.626. So I have 2.6 plus or minus, what is that? 3 point what? 678? Yeah, okay. So 2.6 plus or minus 3.678. So on the low end, I get negative 1.078. And on the high end, I get 6.278.
Interpret.
All right, so the interpretation, it says, do you conclude that there's a difference in the average weight gain? So if we're asking, is there a difference in the average weight gain, what number are we looking for?
0.
We're looking for 0. Is 0 in between -1 and +6.2? Yes. Okay. So we write 0 is within the interval. And so what does that mean? That means we do not have evidence that there is a difference between the average weight gains. That is our answer. All right. How would a 90% confidence interval compare? Would it be wider or more narrow? Or only going to be 90%?
Narrower. More narrow.
It's going to be more narrow. Okay. So a 90% confidence interval will be more narrow than 95%. Yes.
On the final exam, well, you said that it's 550 questions, right?
I'm sorry? 50?
You said it's 50 questions, yeah. Will they be like this, like, you know, like, will
Yeah,
5
yeah.
be a
There's gonna be,
sub-question, or, you know, like, you know what I mean? Will all these 8 or 9 questions be under one as
No,
a
this
sub-question?
would count as 5
It
questions.
will count as 5
Yeah,
questions.
or 6 questions.
Okay.
Okay. Yeah. So I'll have, it's probably, so in the practice final I have like 6 questions related. On the actual final, it's probably like 4 questions related. But yeah. Yeah, it's not going to be 50 questions of 6.
Yeah, thank
That's-
you. Yeah, because I was like, wow, there's going to be a lot of.
Yeah.
Thank
Now this counts as 6.
Okay.
Okay. That's
That's how you set up this last quiz too, right? Kind of deconstructed it, right?
Yeah.
Yeah.
It's like the
Same thing.
deconstructing helps you along the way.
Right.
All right.
Because the question asks, if we put 95%, it's asking.
Okay. All right. So we move on to 11 through 16. All right. So we go to the ruler and yardstick factory. A machine is suspected to be defective. The yardsticks it produces are supposed to be exactly 3 feet long. They measure a random sample of 40 yardsticks and find that the average length is 3.02 feet with a standard deviation of 0.03. Is this evidence that the machine is producing yardsticks that are too long? Okay. 1 sample or 2 samples?
One sample.
Okay. Means or proportions?
Means.
Means. Okay. So 1 sample and it's means. Alright. Number 11, is this a one-sided or two-sided test? One-sided. How do we know it's one-sided? Because the question says, is it producing yardsticks that are too long? Okay, because it says too long, we're asking, are the yardsticks too long? We're not asking, are the yardsticks different from 3 yards, or 3 feet? We're asking, is it too long? So this is a one-sided. So what would our hypotheses be? So we have a null and we have an alternative hypothesis, okay? Again, you can check your study guide, and it says if you have 1 sample means, the null hypothesis will always be mu equals, and I think it says 30 or something. Well, in this case, we want to know, is it equal to 3? And the alternative is mu too long. Is that mu greater than 3? Okay, so figuring out our test statistic, let's list off the information that we have. So 1 sample means we need an n, an x bar, an s, and then we have the mu from the hypotheses. So my n is what?
40.
40. My x bar is 3.02. And my s is 0.03. And my mu from the null hypothesis is 3. Okay? So my test statistic is going to be x bar minus mu divided by the standard error. So let's do our standard error calculation separately. This is s over the square root of n. So I have 0.03 divided by the square root of 40. Okay. And so this, so where you round this might make a difference. If you leave all the decimals, it's 0.0047434. Okay. My test statistic would then be 3.02 minus 3 divided by 0.004743, and I get 4.216. That's my test statistic. Okay. Again, depending on where you round, this number might be off by a little bit, but it should be within the same range there. Everyone's happy? Okay. We'll do number 14, which says there are 30, what's the p-value? Okay, so how many degrees of freedom do we have? We have 40 minus 1. We have 39 degrees of freedom, but we don't see 39 degrees of freedom in our table. We're going to round down to 30. Okay.
Excuse me, can you lower so we can
Yeah,
see?
sure,
Thank you.
So the last number, if we use 30 degrees of freedom, the last number in that thing is 2.725, I believe.
Yeah.
Okay? 4.216 is beyond that, okay? 2.725 corresponds to 0.005, okay? So my test statistic is more than 2.725, so that means my tail area is it more or less than 0.005? My tail is less than 0.005. Is it 0.001?
Yeah.
Let me see.
Yes, 0.001.
Oh, 0.001. That's what I meant to write. My bad. Wait, 2.725 corresponds to 0.00. Did I write this table wrong?
Yeah, I think so.
Yeah. Oh, okay. Let me borrow this. Sorry. My information is 3.385. Okay. 0.001 and 3.385. Okay, 4.216 is bigger than 3.385. So my tail area is less than 0.001. Yes, thank you. Thank you. Sorry. Okay. Do I leave it as is or do I double it for my p-value? Leave as is, right? I've got a one-sided test, so my p-value is less than 0.001. Okay, so there's our answer there.
Where did you get why did you write 4216 there?
That's my test statistic that I got.
Oh, down there. Oh, okay. There you go. Thank you.
All right. So if alpha is 0.05, what's my conclusion? My p-value is less than alpha. So I reject the null hypothesis. Okay? So that means we have evidence that the machine makes yardsticks that are too long. Alright, so if this was a mistake, if it was a mistake to reject our null hypothesis, what kind of mistake did we make? A type 1 error, okay? Number 16 is a type 1 error. Type 1 is, it's a mistake to reject the null, and type 2 was, it was a mistake not to reject the null.
When did we learn that?
I know.
Sorry.
It's in the book.
We talked about it, I think last week, and then, no? Okay, maybe a few weeks ago. I'm pretty sure we talked about type 1 and type 2 errors somewhere along the way.
Well, would you mind just writing down the definition?
Yeah, okay. We will do that.
How many points would that question be worth?
There's probably 2 questions.
It's like a 2-point question, right?
Well, I don't, there's, all the questions are worth the same.
Okay. I mean the type 1 question.
Huh? Alright, okay.
What?
Type 1 error. There's... Okay. So when you do a hypothesis test, you have a null hypothesis and an alternative. And one of those is true. Okay? You don't know which one is the truth. So type 1 error is you have rejected the null, but the null hypothesis was actually true. Okay? So your decision reject the null hypothesis. But this is a mistake because the null hypothesis was actually true. Okay, so that's why it's called an error, right? Because if the null hypothesis is true, you don't want to reject it. So type 1 error is you've made the decision to reject the null hypothesis, but the null hypothesis was actually true. Darn it. And a type 2 error is the flip side. Your decision is not to reject the null hypothesis. But you should have because the null hypothesis is actually false. Is that all right? Okay, we'll there's a few more points.
So how did you know it was a type 1?
Okay, so the probability of a type 1 error, this is equal to alpha. Our choice for alpha, our significance level, is directly related to the probability of a type 1 error. If you choose alpha as 5%, you have a 5% chance of making a type 1 error. If you choose alpha 10%, you have a 10% chance of making a type 1 error. On the other hand, the probability of a type 2 error, okay, alpha is the first letter of the alphabet. What's the second letter? Beta, okay, of the Greek alphabet. So type 2 error, the probability of a type 2 error is beta.
What's the value of the beta?
Beta, the calculations for beta are not easy, so we're not going to worry about that, okay? But you should know, you should be familiar, that alpha is the probability of type 1 error, and beta is the probability of a type 2 error, okay?
What chapter was that?
It should be like chapter 8. Somewhere in chapter 8, okay?
Okay.
And then we have something called power, which is the complement of a type 2 error. This is 1 minus beta. Okay. Type 2 error is your decision is not to reject the null, but the null hypothesis is actually false. Power is the complement of a type 2 error. So what would that be?
Your decision is
So
to reject.
complement of type 2 error. So power is you correctly decide to reject the null hypothesis is false. Okay? So this is a good thing. You decide to reject the null hypothesis, and the null hypothesis is false. So this is a good thing. Okay, there's a question?
Yeah, for the exam, are we gonna just be looking at the type 1 and type 2, or do we also have to, for the alpha, are we also putting that as part of type 1 and type 2 error?
Yeah, okay, so everything I put up on this board is fair game for the exam, okay? So yeah.
Because we're not writing it.
So you need to understand what a type 1 error is in the context of our problem, or what a type 2 error is in the context of our problem. So in this case, I asked the question, our decision to reject the null hypothesis was wrong. Okay, because it's number 16 says, if that decision, your decision was wrong, what kind of error did you make? So in step 15, we rejected the null hypothesis. If it was a mistake to reject the null hypothesis, is that a type 1 or a type 2 error? That's a type 1 error. Because a type 1 error is we rejected the null hypothesis, but it was a mistake.
Got it.
All right. Is that okay? So during office hours, I told this story. So you can think of it this way, all right? Let's say you're walking along the street and you see this scruffy-looking man, all right? And he holds this thing. He says, "I found this lotto scratcher, okay? And it's a winner. It's worth $10, but I need the money right now, so I'll sell this to you for $5." Okay? So he says, "This card is worth $10. I'll sell it to you for $5." Would you take him up on the offer, or no?
I would.
Maybe not. Okay, so you have a choice to make. All right. So you could choose to believe the man, or you could choose not to. All right. Those are your choices. You could choose to purchase the ticket for $5, or you could choose not to. The truth is, he could either be telling the truth, or he could be lying. Okay. So in this case, if the null hypothesis is he's telling the truth, okay, then committing a type 1 error is you say, "No thanks, I don't trust you, you're a stranger, I'm going to keep my money," and walk away, all right? But a type 1 error would be he was actually telling the truth, all right? That card was worth $10. You could have made a quick $5 if you bought the ticket from him for $5 and he gave you something that's worth $10, okay? So that would have been, that's a type 1 error. You rejected the null hypothesis, but the null hypothesis was actually true. Okay. On the other hand, a type 2 error would be you believe the man, and you say, "Oh, okay, give me that scratcher. Here's $5," but he was telling a lie. Okay. So type 2 error is you've accepted, or not accepted, but you didn't reject the null hypothesis. You didn't reject what this man was saying, but the truth was the null hypothesis was false. He was lying to you. So that's a type 2 error. Okay? Both of those situations are less than optimal. Okay? In type 1, you're missing out on a potential $5, and in type 2, you lose your $5 outright. Okay? Ideally, we could always tell who's telling the truth and who's not, and we could just only deal with honest situations, but that's not reality. So, yes. Yeah.
Is there another power, like if you correctly decide to not reject the null?
You decide,
and you do, and that's right.
Okay, there is, in the medical field, it's called the specificity of a test, okay?
So for this, it's not.
But we're not going to worry about it, okay? That concept does exist, but we won't worry about it, okay? So power is how well can you reject the null when the null hypothesis is false. Okay? All right. Good?
Good.
Good. We shall carry on. Can someone tell me what time it is? What's that?
7:30.
7:30.
Yeah.
Okay. Someone give me like a 10-minute warning for 8 o'clock, 7:50, and then because at 8 o'clock we'll take a break, but I have to do student evaluations or instructor evaluations. Okay, so you guys get to grade me. All right. I should have brought cookies, huh? Okay.
You don't need it.
Huh? All right. Researchers believe, this is number 17. Researchers believe that 14% of the population is left-handed. A local school decides to see if their students have a different proportion of left-handed people. The school has a total of 1,500 students. They randomly select 90 for the survey and find that 15 of them are left-handed. Is this evidence that the proportion of left-handed students at the school is different from the population proportion? Okay. One sample or two samples, means or proportions? One sample proportions. Okay, great. Alright, what's our sample size? 90, okay, and then the number of left-handed students? 15. And what's the P in the P that we're testing? 14%. Okay. But number 17 asks, what is our sample proportion? So that's P hat. That's going to be 15 over 90. So I get 0.1667. Is that right?
Mm-hmm.
Okay. Notice that's different from P. Alright, 18 says we're going to make a confidence interval. If it's a 90% confidence interval, what critical value Z star do I use? Okay, this is just one of those numbers that you need to have written down or have memorized. Z star for 90% is 1.645. Okay, my standard error for a confidence interval, it's P hat times 1 minus P hat over N. Okay, you can check your study guide, but it's different for a confidence interval from a hypothesis test. Hypothesis test, we're using P. Confidence interval, we use P hat, okay? So make sure you keep that straight. As a distractor answer, there will be one that uses P, all right?
Say what you just said again. Between P and P hat.
Confidence interval, the standard error uses P hat. Hypothesis test, the standard error uses P. Okay? So, you know, when you have multiple choice, one of them will be the answer that you get if you use P, and one will be the answer you get if you use P hat.
Wait, sorry, hypothesis test uses P and what is it?
Confidence interval uses P hat. .1667 times 1 minus 0.1667 divided by my N is 90. Punch this into your calculator, you get 0.0393 or something like that. When he asked, what is the center of our interval? That's just going to be P hat, which is 0.1667. 21, we put all of this together, P hat plus or minus Z star times our standard error. 0.1667 plus or minus 1.645 times 0.0393. And when I do this, I get on the low end 0.1021, and on the high end, I get 0.2313. Yes.
So the answer for 17 and 20 is the same?
Yes. 17 is what's P hat, and 20 is what is the center of the interval, which is P hat.
Okay.
Okay. 22. Okay, do we have evidence that it's different from 14%? No, right? We are seeing is 14% in the interval, so we say 0.14 is in the interval. Okay, so we do not have evidence that our school's proportion is different from the national average. Our national proportion. Should I slide this up a little bit? Is that better? Alright. Is that good? Keep going? Alright. 23. You buy a bag of Starburst candies and a bag of Jolly Rancher candies. The bag of Starburst contains 80 pieces and 12 of them are cherry flavored. The bag of Jolly Ranchers contains 70 pieces and 14 of them are cherry flavored. Assuming that these are truly random assortments, does this provide evidence that Starburst and Jolly Ranchers have a different proportion of cherry flavored candies? Alright, so group 1 is the Starburst with 80 pieces total and 12 cherry. And group 2 is the Jolly Rancher candies with 70 pieces total and 14 cherry. It says perform a hypothesis test at the 0.05 significance level. Okay. One sample or two samples means of proportions. Two samples and proportions. Okay. 23. What are our hypotheses? So, hypotheses with two sample proportions is going to be P1 minus P2 equals 0, or P1 equals P2. Also equivalent. Be prepared to see either form as an answer choice. And the alternative, we want to know, do they have a different proportion of candies, cherry flavored candies? So that would just be P1 minus P2 not equal to 0. Or the alternative being P1 doesn't equal P2.
But it says improves.
Huh?
It says improves.
Oh, you're looking at question 28 through 33. That's the, so we want to know, yeah, if it said, do we have evidence that there are more cherry candies for the Starburst or more cherry candies for Jolly Rancher? Then yeah, then we have different, then we would have a greater than or a less than there. Okay. Okay, 24 says, what is P hat? P hat is the total success divided by total observed. So that would be the total number of cherry candies I saw, 12 and 14. I saw 12 and 26, divided by the total number of candies total, 80 plus 70. So we have 26 divided by 150. My p hat is 0.1733. Okay, number 25 says, what is the test statistic? So on the quiz, I saw a lot of people make mistakes here, like they gave the standard error. They found the standard error correctly, but they said that was the test statistic. That's not. You gotta go through the entire process. Okay. So the standard error is going to be, all right, and this is just two sample proportions. That's going to be p hat times 1 minus p hat times 1 over n1 plus 1 over n2. 0.1733 times 1 minus 0.1733 times 1 over 80 plus 1 over 70. And this gives you some number.
Point 0619.
Yeah.
Point zero what?
0619.
Okay. All right, and then the test statistic, though, okay, is we got to do z is equal to p1 hat minus p2 hat, technically minus 0, divided by the standard error. What is p1 hat? P1 hat is 12 over 80,
0.15.
0.15, and P2 hat is 14 over 70. 0.2. So my z is going to be 0.15 minus 0.2 divided by 0.0619. So here I got negative 0.81. So what we got? Okay, so that is my test statistic. I'll let you guys catch up when you're writing. Okay, so number 26 says do a hypothesis test. Okay, so what do I do with my test statistic? I look this up in the table. Which table am I using? Z table. Proportions mean you're always using the Z table. So I go to my Z table and I look up negative 0.81. Okay? So if I look up Z equals negative 0.81, the area in my tail is equal to 0.2090. Do I leave my tail area as is, or do I double it for my p-value? I double it, right? My alternative has a not equal sign, so I doubled it. So my p-value is equal to 2 times 0.2090. I get 0.4180. That's my p-value. So number 27, if my p-value is 0.4180, what do I do with the null hypothesis? We do not reject the null hypothesis. We do not have evidence that the proportion of cherry candies is different.
So can you do a type 2 error if you make a mistake or?
Yeah, so this is a good question. If this decision was a mistake, what kind of error did we make?
Error 2.
Type 2, because we did not reject it. So a type 2 error in this context would be, we come to the conclusion that, or we don't come to the conclusion that they're different, okay? So we say we don't have evidence that they are different. But in reality, the candy factories make different proportions of cherry candies, okay? Who knows? How many flavors are in a Starburst bag? You have yellow, orange, pink, and red.
But if you get the tropical one, it's different.
Yeah, the original. Is it past 7:50? Okay, so let me pass these out. Okay, pause our video here.